Okay. All right. So, give me some ideas of what you might want to try to do here.
Let's see.
Well, we know, so if we have a set that begins, that contains the positive integers and starts just at any finite point in the negative numbers, we can always show that that's equal to this set.
Oh, how would you do that?
Because we can just add, wherever it ends, we can just add that number plus 1,
Uh-huh.
and then our starting number is now 1.
Okay, good. So if I started at like -1,000, it would be easy to figure this out. But unfortunately,
We can't add infinities.
I'm starting at minus infinity. But that's a good observation.
I think they talked about this thing in the book, but they used a graphic picture.
Oh, they use a picture. Okay, well that's fine. Let's see if we can just figure out something to do here. So we got to hit all the negative integers, we got to hit all the positive integers, and we got to hit 0.
Yeah. Because it seems like we can't, if we doubled the size of this set, so we had each number in here twice,
Uh-huh.
and then flipped, and then just made one copy negative, we would have this set, essentially.
Okay, why did you say essentially?
Because we would miss 0.
We would miss 0.
But we
How
can-
would you fix that?
We can just subtract 1 from, say, this set to get 0.
Okay, so that's a fantastic idea. So we make 2 copies of this set. And what would you do with this set?
So we can make this set negative and then add 1 to it. Add 1 to each number in this set.
Okay, and so where would this set,
So
where would that set go to?
This set would go to these numbers.
Alright, and where would the bottom set go to?
These numbers.
Okay. Alright, do you see how that
Yeah.
works? Okay, now, have we produced a bijection between our numbers and the original set yet?
No.
No.
Okay, why not?
Because we produced the bijection between these numbers and 2 copies of the original set.
2 copies of the original set. So it might be that this is twice as big as this one, which wouldn't be that surprising. But now let's see if we can solve the problem by now finding a bijection between the set of integers and 2 copies of itself.
Yeah.
Alright? So that's a nice thing that you've done. You've broken the problem down. You said, wait a minute, I can solve this problem. If I had 2 copies of the integers, I could send it to the negative and positive integers. So now all I gotta do is figure out how to send 1 copy of the set to 2 copies of the set. What can I do?
Well, could you subtract 1 from every other member of this set? So you subtract 1 from all the even numbers in this set.
Okay.
So that would produce 1, 1, 3, 3, 5, 5.
And then we'd have to double it again. So that does not quite work. So we need to get both these somehow.
Yeah, we need to get 2 copies here.
Well, then could we be building on that idea? We could subtract 1 away from this, 1 away from this, and 2 away from that. But then we have to subtract different amounts for each set.
Okay.
I'm not sure if that's a bijection, if you have to like subtract a distinct amount away from each number.
Well, it's still a rule. Where would you send the number 1? Draw the arrow. Where
1
would
would
go?
probably just go to a 1.
Okay, where would 2 go to?
Well, the
If we're
easiest.
subtracting one, we'd probably just go to another one.
All right.
Yeah.
Okay. Where would 3 go to?
3 would probably go to 2.
All right.
And 4 would go to another 2.
5 would go to.
3.
6 would go to.
Another 3.
All right. So let me write down 6, 7, 8 here. Okay. Where would 7 go?
7 would go
4.
to 4.
All right.
8 would also go to 4.
All right. You see what the rule is here?
So, for the odd numbers, we're doing plus 1 over 2. And then for the even numbers, we're just doing over 2.
Yeah.
Well, there we go. So we want to map this infinite set of the positive integers to 2 copies of itself. But it turns out we have 2 copies hiding inside of it.
Yeah.
What are they?
The even numbers and
Numbers.
the odd numbers.
The even numbers and the odd numbers. So the odd numbers go to 1, 2, 3, 4, 5.
Mm.
And the even numbers we just divide by 2. And they go to 1, 2, 3, 4, 5. Pretty cool.
Yeah.
Yeah.
And that's a bijection because we can talk about the third even number and we can talk about the third odd number when we're talking about positive integers.
Yeah.
All right, cool. Let's talk about that diagonal argument though. Now.